Stand. Stand.
Whoever's watching, I'm back. Remove the banner. There we go. Yeah, should feel good. Should feel good. Is audio okay? Let me double check audio. I should have that habit of checking the audio each time. Let's see. I'll just mute myself real quick so we don't have echo. Let's see. Hello, 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 hello. Awesome. As you can see, like 3-4 seconds of delay. I hope that doesn't create a little bit of noise, but yeah, I think 3 or 4 seconds of delay is good. Awesome. Hello. Hello. Thank you for joining. Nice. Okay, first of all, just put my iPad where it should be. So I have my cheat sheet right there. It is where it has to be. There we go. Cool. And before we start, there you go. That's the link to register for this stream. Yep. Nice. Okay, so let's start. Welcome to Data Science 101 with Pandas. Pandas is a Python library. So let's start. Let me double check my yep, microphone's okay. Cool. Awesome. So let's add this to the stage and start. Slideshow this. Awesome. So again, welcome to Data Science 101 with Pandas. My name is Charbel. People call me Bully. I am a robotics and telecommunications engineer. I am from Puebla, Mexico. I live in Puebla, Mexico. In the fellowship side, I was a fellow of batch 3 for production engineering. And since 2022, I've been a pod leader up until 2025, last year. And I started as a program coordinator. I'm also pod leading when we need. So yeah, if you're in the fellowship side, if you want to be a fellow, want some tips and tricks, just let me know. DM me either on Discord or LinkedIn, or send me an email. Here's my email. Okay. By the way, on Discord and LinkedIn, sometimes I do forget to reply, so please spam me. Okay, it's okay, right? Like I usually forget. And there's my GitHub. Okay, awesome. Those are my socials. Cool. Okay. So, this stream is intended for people who are not familiar with data science, or maybe just a teeny tiny bit, and are just curious to learn some first steps into data science. Okay, what is data science? So, data science is basically the science, the discipline that collects, digests, and shows the data for something. Okay, for example, the case or the most used case nowadays is for AI. Okay, so you're training your neural network. You have a lot of information in your images. Okay, so you have to go image by image. And you have to separate the images. You have to tag them or annotate them. And you have to create the bounding boxes of those objects, stuff like that. Okay. For example, if you're working for Netflix, okay, then a data science project for you would look like you are training a machine learning model that understands the user's preferences of movies and TV shows. Okay, so that's what it is. Okay, it's basically taking a lot of data, compressing it down, digesting it, so we get rid of all of the noise and unused or unuseful data, and yeah, basically just use what we have. Okay, here it says one, data collection. Okay, one of the let's say maybe priciest steps when training machine learning algorithms is a data collection. Okay, sometimes there is not enough data, so you have to do it yourself. So people usually, for example, for Tesla, and all autonomous vehicles nowadays, they use data from people that are driving. They basically film, record everything, and then send it to the cloud, and they use that new pieces of data to train the model. Okay, so data is really expensive. Okay, here it says data augmentation. Yeah, data augmentation is when you basically you don't have enough data, and you use the current data that you have to noise it a little bit so that it becomes new data. Okay, so for example, an image, you can have an image, a blurred image of that original one. So you have the original, the blurred, the rotated one, stuff like that. Okay, that's data augmentation. Cool, yeah, awesome. Data collection, data processing. You have to process the data, which is really, really, really tedious. You have to analyze the data, model the data, and visualize it, or send it to your machine learning algorithm. Okay. That's data science. Okay, it's a science. It's not easy. It's very tedious. You need to know lots of tips and tricks. You need to also know how to manage big chunks of data so you don't run out of memory, so that it's not very slow, stuff like that. Okay. And digesting the data takes a lot of mathematical skill. Okay. Cool. Okay. We're going to use something called Pandas. Pandas is an open source Python library that helps us do some data science, basically. Okay, it's really easy. It's super simple. You can read CSVs, SQL. You can read Excel sheets. It's really easy to use. Okay. Now it's built on top of NumPy. NumPy is built in C++, so this thing is really fast. Python by itself is slow. So if you're going to do data science on big chunks of things, then you have to make sure that you don't run out of memory because it's built on top of Python. Okay, so even though it's built on top of NumPy and it uses NumPy, which is written in C++, it's still Python in the core that's running everything. And Python is both slow and heavy, okay? Because it runs on C++. So just make sure that if you're going to use Pandas for big chunks of data, you just don't run out of memory. Okay, so it's easy to happen. Okay, cool, awesome. So nice. If you have any questions, please let me know on the chat. Okay, cool. So every pieces of code, you'll find them here. I don't have this notebook that I will create together here yet. I'll post it just after the stream. Okay, so if you want to find the pieces of code, it's here. Okay. What do you mean by is that why Polar is created? But yeah, okay, cool. So we don't need to install anything. We won't run anything in our computer. Let's go to Google Colab. If you don't have Google Colab, if you don't know basically what Google Colab is, yeah, there you go. It's a notebook of Python, or a Python notebook. Okay, Polars is better than Pandas. That is what I've heard. I've never heard of Polars before. Let's see. Databricks. Okay, Polars. Python. Let's see. Okay, I don't know. I've never used Polars before. I didn't know it existed. Oh, that's cool. See that? Pandas 207 seconds. PySpark 55 seconds. Polars 8 seconds. Maybe. So this can run in Python really, really fast. Yeah, I should check Polars out. This is really cool. Thank you so much for sharing. I didn't know that this existed. Nice. Okay, let's focus on Pandas today. Nice. So you can see I have a lot of notebooks here. You'll maybe greeted with something like this. Okay, this is a default Google Colab notebook. So we're not going to use it. Okay, you go to File, new notebook in Drive. It opens a new what's this called? It's the what's this called? Stop. What is this? It's a Chrome tab. Sorry. It opens a new Chrome tab. Okay, cool. So first of all, we'll need to find data. Okay, we cannot do data science without data. There is a very cool webpage called Kaggle. Okay, if you go to Kaggle, you can find a lot, and by a lot I mean a lot of data sets. Okay, the data sets are sets of data that people post here, and you can freely use. Okay, yeah, it's a Python notebook or a Jupyter notebook. Yeah. People sometimes just call them Jupyter notebooks. In this case, it's not Jupyter, it's IPYMB, which is the Jupyter notebooks ending. But yeah, it's either a Python or a Jupyter notebook ending. Cool. So this is Kaggle. Okay. You can look for, I don't know, for example, brain tumor. First one. This is a notebook. Someone just create a notebook with a model here. Let's go to datasets. And in this case, for example, you can find images of brain tumors. Okay. This is how it looks. Okay. You can see, for example, a little preview of this. And let's see, can we see the images? We can, but you can see here, it says it has 3,764 files. 3,762 of them are JPG images, 2 are CSVs, which I'm pretty sure are either YOLO or another computer vision model description so that they understand these files. Okay, cool. This is Kaggle. Okay, we're not going to use brain tumor today. We're going to go to something easier. Okay, these are images. We won't get to images today, but we can go to BMW sales 2010 to 2024. Excuse me. I'll say what? Is Yusuf? Let me look for this. Searching Google. Yeah, I think it's easier. Kaggle BMW sales 2010 to 2024, and the author is Y0 Yusuf and Dale. There we go. Here it is. Yep, Google is way easier. Cool. So these are, or this is the dataset that we're going to use. What is this? Let's read together. This dataset contains detailed BMW sale records from 2010 to 2024, covering multiple regions and model categories. Okay, cool. So we know what to expect. We expect sale records from 2010 to 2024. Okay, cool. Now you can see we have a graph here, or like a chart with graphs. We can see that we should expect a model, a year, region, color, fuel type, oh, my bad, transmission, engine size, mileage, price, and sales volume. Okay, this is what we should expect from our data if we use it. Okay, careful, close up time. Sometimes Kaggle datasets are wrong. Always, always, always check your data. Don't take anything for granted. You might run into some errors, unexpected errors that you don't know where they come from. In the end, it's bad data. Okay, so you have to clean it up yourselves. Okay, cool. Close up time outside. There we go. Cool. So we want to use this. Okay, how can we use this into 101 Pandas data science? So how can we use this here? Do we click download? Don't do that. That's not the almost optimal option. In the end, you might download big data sets, like a couple of gigabytes or more, and it's not necessary. Okay, let's follow this. Okay, it's if you haven't used a Google Colab notebook before, it's the same as running Python. If you don't know what a Google or like a Jupyter notebook is, you have these slots where you can write Python codes. For example, print here. I can run this. It should connect. It's connecting now. Let's give it some time. Ignore the cats. I love having cats there, so yeah, ignore them. Come on. Do you imagine if it says, I can't find the server right now? It's gonna be hilarious. So hilarious that I think it's going to happen. What? Is everyone using Google Colab now? What? What? To GPU? I don't need a GPU. Like I could change the runtime to GPU, but I won't process any images. So that's it's actually harder to find GPUs than usual CPUs. So now I will stay in the CPU. But yeah, that's weird. What? Should I refresh? Yeah, I don't care. That's weird. Connect. Ah, there we go. Cool. Awesome. Nice. Okay, so here, Vishal says, hey, you can go to this arrow here, change runtime type, and you have for free a CPU, a T4 GPU, or a V5E TPU. TPU stands for Tensor Processing Unit. We won't use tensors now, so no use. If you want to use a GPU, you can use a GPU, but if you don't process images, it won't you won't feel the difference. I don't I don't recommend using a GPU right now. People might be using a GPU or might need a GPU, and if you're not processing images, then just don't use it. Okay, use a normal CPU. Okay, cool. Now, if you're paying for Google Colab Pro, you'll have all of these available. Okay, cool, nice. So awesome. So you can see if I click print here, it says here, and if I say here print, I don't know, let's do a equals 1, and here I'll do a equals 0, right? So if I run this, a is equal to 0. If I run this again, my bad. Now it's 0, now it's 1. And if I go back here without running this part, a is equal to 1. Okay, so even though I didn't explicitly say what a was here, since I ran this chunk first, it recognizes a. Okay, so both slots are connected, and you can run them separately, and nothing will change. Okay, so if I change something here, it changes here. Okay, that's what a notebook is good for. Okay, so it's not a big Python script. It's, let's say, a chunks of Python scripts. Okay, cool, all connected together. Nice. So let's start with import the data set from Kaggle. And by the way, before I do that, I have to sign in because you need something. Okay, well, that I just signed in. Go to your settings. Okay, when you go to settings, I think it's in code. No, is it in where was it? Wait a minute. Home, more, host, blog, teams, privacy, blah 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 blah. You need a key. The key, in order to get the key, is here it is. Okay, in the settings part, if you scroll down, you have a token. Okay, so you click on generate new token. I think I have mine here. There you go. That's mine. Yeah, there you go. So in my downloads, I have Kaggle here. It's a JSON file. Okay, so this is your key. You have to have your key. Okay, so go to Colab, click on these 3 dots. No, here. No, where was it? Oh, sorry, here in the folder. In the folder, you click on this up arrow. And in my case, it's all the way down here, kaggle.json. Okay. It says warning, ensure that your files are saved elsewhere, because when you reload this, all of these files that are here get lost. Okay. Cool. So now that we have our kaggle.json, which again, you have to go to settings, scroll down, click on generate new token. It'll download a kaggle.json file. Okay. Cool. Now that we have this, if you want to use bash or want to use a terminal, you start with an exclamation point. Okay, so exclamation point pip install Kaggle. Okay, make sure that Kaggle is installed. Okay, next, make there. If you're not familiar with this command, it basically says make directory, which is create a new folder of or called how I don't remember how I wait a minute damn There we go. This thingy, which is the I forgot the name in English. In English. What? Why Arabic? Tilde? Is it a tilde? Virgulilla. No, I want English. Virgulilla. Is that okay? There's a name of this. It's not a tilde, right? It's a squiggly thingy, liney. Okay, it's this thing over here. It had a name. Tilde? I know it as. This is weird, but wait a minute. Origins, context, dash, squiggly line, and it's referred to as swung. Maybe here. Let's do it. A tilde, really? Didn't it have another weird name? I don't know. Okay, it's a tilde. Okay, tilde. Tilde? I think it's tilde. Okay, so you do tilde. Tilde means home directory slash dot Kaggle. Don't forget the dot. Okay, dot Kaggle. Then under it, again, exclamation point, cp4 copy, and then we'll do Kaggle.json, which refers to this Kaggle.json here. We'll copy it where? Here, but you have to specify this / app. Okay, cool. Now, chmod, which is changing the permissions of the file. We're going to change it to 600. Just trust me, okay? 600. Tilde Kaggle dot Kaggle / Kaggle.json. What does this mean? We're giving it permission to execute and read for Kaggle.json, the one that we copied inside of dot Kaggle. Okay. Now, last thing is exclamation point Kaggle datasets. Okay, it has to be datasets. Sometimes some datasets are from competitions. So instead of datasets, it's competitions. In this case, it's datasets. Okay, so datasets download, and then -d for the dataset, and then we'll do y0 SSEFCKANDIL Yusuf Kandil. That's the author of the dataset. / BMW. And by the way, you can find this here. It's this part over here. Yusuf Kandil BMW sales. Okay, let me share this with you. And again, after Yusuf, everything. Okay, so Yusuf and whatever is next. There you go. Cool. Now, we should run this. It shouldn't throw any errors. It'll say, okay, we already have Kaggle. Usually Collab it has already Kaggle installed, but just in case, run it. Awesome. It says, hey, your dataset URL is here. Downloading BMW sales 2024 zip to /content. /content is here. And you can see it magically appeared. BMW sales 2010, 2024 zip. It's in a zip file, okay? We can actually specify here --zip. Okay, but let's do it the old-fashioned way for this one, and then for the next one, we'll unzip it directly, okay? Cool. So, import zip file like this, and then do I'm sorry, wait a minute. It's not like this. From zip file, imports. I forgot the function. I don't have it in my cheat sheet. Wait a minute. Zip file unzip. There we go. Yep, Microsoft support. Nope, not this. Should be this one. Free documentation. Don't go with AI directly. Or maybe. No, not this. Yeah, let's go with AI. Why not? I forgot. Zip file. Zip file. Yeah, that's the one. Capital Z, capital F. Yep, cool. Okay, so import zip file. Okay, so from zip file, all all non-capital letters, import Z capital and F capital zip file. Okay, so what was it for? With zip file, we'll open what BMW. The easiest way to do is click on the three dots here, go to copy path, and paste the copy path. Okay. Again, three dots, copy path, paste the path here, and then the next argument should be in reading mode, which is R. Okay. As F. Okay, so as F, and then we have to do F dot extract all, and then we'll extract it where? Destination folder. In this case, it's /content. Of course, in string. Okay, run it. Nothing happened, or that's what we think, because we already have here BMW sales data.csv. Double click on it, you can see it here, like a preview. There it is. See that, for example, 5 series, 2016, region Asia, color red. It's petrol. For example, the i8. What's an i8? How does an i8 look? Oh, this is sweet. This is really sweet. Okay, that's a cool car. Okay, if BMW wants to sponsor me, an i8 would be good. Okay, so you can see here we have all of the data. But this is not the way to do it. Like, this is not how we actually work with data science. Let's see. Wait a minute. This crashed. There we go. So, no. Let's use Pandas. So, import Pandas as PD. All right, that's the easiest way. Or actually, before Pandas, let's just go the old-fashioned way. Okay. Import CSV. Like this. So you have a CSV diction. What's this? It's not a dictionary. Wait a minute. Sorry. It's the what the heck? It's not a dictionary. And Python. What is it? It's a library. Thank you. CSV is a library from Python, exactly made to work with CSV files. Okay. Not the friendliest, not the quickest, not the easiest, but we want to check or actually see what Pandas is capable of that native Python with CSV can't. Okay, so we have to open it like this with open /content /BMW sales 2010-2024 not .zip, it's .csv. Okay, you got this, and then new line equals nothing. Okay, so we don't have a new line. We don't want it to add a new line, so we don't add a new line. Okay, as F. Okay, usually F is the go-to variable. Nice. So after this, you'd say, hey, we can use it already. Well, not yet. We have to create a reader object. The reader object is the one that basically reads the file. Okay, so reader equals CSV. That reader. What do we read? F. Okay, cool. By the way, let's just comment this. Get the reader object. There we go. Cool. Now, what does this look like? What? A no specified content, BMW sales, what? Dash sales 2010. Isn't this the same? Did I misspell it? It's not. What? Let's do it like this. Oh, careful. It has parentheses here. Click on the three dots, copy path. Maybe that was the easiest way to do it. Paste path. Okay, there you go. It's renamed for some reason. Okay, run this. Maybe it's an error. Let's rerun it again. Let's rerun it again. What is this? Like, does someone know what this means? 0x. What does that mean? Someone in the comments. Do you know what this means? Anything that starts with 0x in computers, what does that mean? Any guesses? Nope. Let's see, I'll give you like, I know I have delay, so maybe 5 seconds, 6 seconds. Nope, no one. Everything that starts with 0x is a memory, it's a location in memory, that's it. So it means this reader is an object that's stored here. Why does this happen? Because we just created an object and stored it. It doesn't know, or we're not accessing the data inside of that location. It's just stored. So we need to digest that. Okay. So let's get rid of this print, which doesn't work. And let's first row is the header. Okay. So header equals next reader, like this. And then we got the header. Get rid of the header. What's the header? This is the header. Model, year, region, color, fuel type, transmission, engine size L, mileage km, price USD, sales volume. All of these are the headers. Okay, get rid of that. And then for row in reader. Oh, wait a minute. I'm writing in comments. Print rows. So for row in reader, print row. Let's run this. Okay, it takes time. Ah, there we go. See that? Now let's scroll all the way up, and if my theory is correct. Oh God. What? This is a lot of data. Wait a minute. Let me just unzoom a teeny tiny bit. There we go. See that? So we don't have a tuning output truncated the last 5,000 lines. Okay, so the last one. Okay, but the first one, remember, it was oh no, the first one was a hybrid. So wait a minute. Let's have a counter here. I row in enumerate reader, like this. If I double equals 5 or 6, whatever, let's just do 6. Print row. Actually, this is break. Like this. Okay, let's run this. Cool. We got only the first 6 lines. Okay, and you'll see we don't have a header. How does that look? Or let's just print the header. Okay. It says model, year, region, color, fuel type, blah, blah, blah. Everything that we said, it's stored in header. Okay. Rows are each rows. You can see the first one is a 5 series, 2016, Asia, red, petrol, blah. The next one was the cool i8. Then we have a 5 series, an X3, 7 series, 5 series, and then the header. Okay. Now, this is not very useful. Like, you just got a list of the row, and I don't know how many lines we have. Do we know? 11 columns. Maybe we can do. Oh, it's easy. Maybe we can do. Let's just store. should be print len of rows. Oh, sorry, actually, reader. There you go. Is it dot data? No. Maybe the easiest way to do it then is, if we actually, print here, row I. There you go. It should take some time to there we go. It has 49,000 rows. So 49,000 lists of data, it's not the easiest way to manage this. So data science is always about making data digestible, easy to manipulate. Okay, so maybe let's do it differently. With open, maybe I'll zoom in a little bit. Again, this string right here, content BMU sales CSV in string as a reading type as f. Oh, by the way, actually not. It's not reading type. Is new line equals nothing. And then under it, we can do the same thing. Reader equals, but this time CSV dot dict reader. Okay, so it's maybe easier if we use a dictionary. Okay, so let's try it. Let's try it. What do we read if? Okay, so for row, I said in reader, you have to remember that this is a dict. Okay, so print will do row in model. We'll print only the models of each row. Would that work? Okay. Okay. So we end with an x1. Let's check that. In our previous print, the last one was an x1. Okay, remember we printed here after it the header, so ignore this part, this one right here. But we see x1 i3 5 series, x1 i3 5 series. So this is easier, right? Like you can just manipulate here the you can manipulate everything using a dictionary. This is cool. Why should we use pandas? Okay, let's try to do some data science with this. We'll import collections. So from collections, not yet. Maybe let's start with total. Count equals 0, 0, like this. Now, let's do some simple stats or simple statistics, okay? So again, same thing with open, this same thing. And remember, new line equals nothing as f. We'll store it in a dictionary. So remember, reader equals csv.dict reader, like this. And then what do we read? F. Awesome. Now, let's get the rows of, let's get a list of dictionaries. So we can do rows equals list of reader. Okay, reader. There you go. Awesome. So and now that we have this already stored, not printed, then we can do prices equals int, actually a list of integers. Inside of that integer, we want to do r in price underscore USD, careful with capital letters, for r in rows if we have our in price underscore USD. Okay, let's explain that step by step. Maybe a little bit of zoom. Prices is going to be a list of integers. That integer is going to be R in price USD, which is one of our headers. You can see it here. Price USD. Okay, one of the headers. So we want the column of price USD for each row in rows if we have it. Sometimes it doesn't exist or it's none. Okay. Let's check it out. Say what? Oh, it's princes. There you go. Yeah, thanks so much. Yeah, I saw the princes instead of prices. Thank you. Okay, we have an error dual. What's the string? It's like not generator. What? Where's the error? Int argument. Oh, my bad. It's this, like this. Not here. So it's integer of this for each rows that exist in price USD bracket. Yep, thanks so much. Cool. Awesome. So now we got a list of all of the prices of all of the cars in one single list. Okay, let's check it out. Len of prices. 50,000. Okay, remember it was 49,000-ish. Now it's 50,000. Okay, cool. Now, this is good. Let's do some stats. Let's do models equals. I'll just scroll up just so you can see. Same thing. Brackets for lists. Why are cards there? Well, that's a great question. If I go to tools, I go to settings. You go to miscellaneous. I can have corgis instead. Yeah, so a corgi will pass now. That's a great question. Yeah, there you go. Okay. I like cats, but yeah, I wouldn't have a cat ever. But yeah, I'd like to see cats. There's a corgi. Cool. Okay, so you can do int. Instead of that int, do the same thing. Yeah, if you refer to the corgis, it's only Google Colab. If you're referring to this, yeah. Nice. So we have an R here, same thing, but instead of price USD, we're looking for models. Models what with capital M. Model for R in rows if R model. Okay, why do you do this? Why is this important? Or actually this part right here. If this for some reason in your data is corrupted or doesn't exist, and you include it, you'll get a bunch of errors in the future. So let's not have that, okay? Cool. Now, oh, careful, it's an N instead of an L. Model and model. Okay, cool. Now, we can print an F print to have variable inside of your print. All car prices. And then inside of the curly brackets, we can put prices like this. Then print maximum or actually minimum price for a BMW is going to be min of prices like this. Okay, print and F print again. Max price for a BMW and model. Maybe no. Let's just give it as for a price for a BMW. Okay, what BMW I said. Then this, and then we'll do max prices. Okay, like this. Where's the error? What? Google Colab is weird. Hello. Nice. Now the last one's going to be print most common cars, and the most common cars are going to be, we need something called counter. Okay, we actually didn't need that. Wait a minute. Import, or actually from selections, import counter, capital C. Careful with this one, capital C. Okay, we'll get counter, or actually it should be in a variable counter. In models dot most common, and should be inside of two brackets or two parentheses, 3. Let's see how that looks. Great. Int our model, what does it say? Literal int. Oh, wait a minute. Why is this an int? Shouldn't be an int. Sorry, my bad. Should be like this. Our model for int roast model. There we go. Cool, awesome. So we got all the car prices again. We got the minimum price for a BMW. In this case, it's 30,000 USD. Wait a minute. USD to Mexican, which is Mexican pesos. 30,000, 500,000 pesos. Oh yeah, 500,000. Well, yeah, I guess I'll get something else. The max price for a BMW is, say what? $120,000. Wait a minute, what? Really? Woo, 2 million pesos. That's what a house. Like that's the price of a small house here in Mexico. No. Okay, most common cars. We can find the 3 most common cars are 7 Series, priced at no. This is the index. The i3 and i8. Okay, and these are the concurrences. 4600-ish, 4600 and 4602. For, I don't know, for 20, 30 cars more or less. Okay, so you can see, you can say, hey, you know what? It's okay. Like we can work with this. It's fine. I don't know. It's too messy. What if we do it easier? Click on new code. Let's import pandas as PD. Okay, let's run this cell. Leave it there. Cool. Now we have pandas as PD. Okay, by the way, if you need the code here, just leave it for 2 seconds while I drink some water. And you see, you need, for example, to import counter in this case, for you to count the most common ones. It's a little bit of a mess. You need a lot of different libraries just to do some data science. Okay. Let's get into pandas. So now, we have to understand the difference between a series and a data frame. Okay, a series is this. S equals pandas dot series. Careful with the capital S. Inside of the series, we have 10, 20, 30. Okay, like this. And then the index of the series is going to be A, B, and C. Okay, now let's easily print S. Well, that's what it looks like. Okay, a PD.series is something that has an index and a value to it. Can we do more? For example, what happens if we do maybe like this? Another list of, I don't know, 1, 2, and 3. Let's see what happens. Maybe the same index applies to 10, and maybe 1 will appear just right here. Length of values 2 does not match with length of index 3. So this length doesn't match the values of index. Okay, so we need 2. It means doing this, maybe? Okay. But it didn't do it, right? Like, it's a list with this index, but it didn't get 3 columns. Or 2 columns, 10 and 1, 20 and 2, 30 and 3. So you can see that a series is a 2-dimensional, let's call it, in this case, data frame, okay? Where we have only one index, and for each index, we have a value, like a dictionary, okay? That's what a PD series is, okay? We won't be working with PD series, at least not now. You can do something interesting with Pandas. We have it as s.info. If you don't know what it is, just run this command, and it says, hey, it's a Pandas core Panda series. It has 2 entries, A to B. Series name, it doesn't have a name. We can do s.name equals something. No null count to non-null. Okay, non-null values are 2, which is 10, 20, 30, and 1, 2, 3. Okay, and the types are objects, and we use 32 plus-ish bytes, nothing. Okay, this is cool because you can get a lot of your useful information thanks to this. Okay, cool. So now, by the way, what happens if we do this? If we return it as it was, like this, A, B, and careful, C. Rerun this, and now it's not the type object. It's the type int64. This is an int64. Okay, awesome. So, and now let's recreate this with Pandas. You'll see how easy this is. DF stands for data frame equals pandas that read CSV. Okay, it reads the CSV. Which CSV? This one right here. Okay, not the zip one, the CSV one. Inside of string, like this. And let's print df that head. Head, it gives you the first 5 rows. Okay. Cool. There we go. It's a one-liner. It's not this whole thing. It's just a one-liner, and that's the coolest thing. I haven't used polars. Okay. Here someone talked about polars. Here maybe polars is better than pandas, but hey, at least this looks magical to me. I'll try to see what polars is. Maybe I'll do a stream on polars, but yeah, pandas, this looks cool. You can see model 5 series. You can get the index here, the year, and everything that the actual CSV has. Cool. Awesome. So what can you do with this? For example, we can do the same thing, df.info, run it, and you can see now it gives you a more detailed explanation of what you have. Model, year, region, color, fuel type, transmission, engine size, mileage, price, sales, and sales. All of them are 50,000. No. Okay, this is really, really, really helpful. If one of them is corrupted and you get a null type, it'll tell you, hey, careful, you have 49,999 non-null and 1 null. And you'll see, hey, I'll have to delete the entire row because I don't know what it is. You can just guess the number. You have to delete it because it's a corrupt row. Okay? In this case, we know it's an object in this case, which is string, N64, maybe string, float 64, N64, and string. Yep. Cool. You can see here, always check your memory usage. When you have very, very, very large data sets, this is very important. You'll feed it to a neural network. Neural network is going to crash. Okay, you run out of memory. So careful here, okay? You can check your memory stats here. We are using 1.4 RAM out of 12. and 20 gigabytes of disk out of 107 of free space. Okay. Cool. Now, after that, what else can we do? Cool. So let's do the same thing. Like, let's do this. What took us 1, 2, 3, 4 lines of code. Let's do the same thing with pandas. You can index pandas using as if it was a dictionary. df in model. Let's do dot ahead, which is the first 5 lines. Oh, there you go. See that? Easy, one-liner. Cool. Now, what happens if you want 2 of them? So 2 columns of data. Let's do df, list of lists, model, and price underscore USD. Ready? That ahead, so we only get 5. Now we will get the entire output. Say what? Oh, I'm sorry. Model with L. Ooh. That's pretty powerful. Look at the model. The 5 series costs 98,000. What's a 5 series? It's better dance. Okay, it's pretty, but is it cool in the inside? Oh, that's cool. Okay, I'll give it to you. 100,000, maybe worth it. Oh, let's see. It's a what? It's a 4-cylinder and a 6-cylinder petrol engines. Oh, that's turbo. Okay, yeah, I get it. Okay. If you get an M model, you get a V8. Yeah, way to go. Cool. Okay, so nice. Now, this is how we get columns, entire columns. What happens if we want actual rows? Okay. Hey, I need the second row. How do I actually index that? And you'll say, hey, it's easy. df in 0. And an error happens, and it says, hey, there's no 0. Maybe not. Maybe 1. Hey, there's no 1. Maybe 10. There's no 10. So the way to do it, or index the entire what is it, row, right? You have ilock. You do df dot ilock like this. It's not I love, it's ilock. And now you get a list and you'll give it the indices that you want. Okay, let's get row number 0, column number 1. Okay, let's see what happens. Let's see that again. Okay, it's row 0, column 1, which is the second column. It's the year, right? Is it a year like this? Yeah. Okay. Yeah, see that? From the first row, we got the year, which is the second column. Okay? You can see model is the first, year is the second. There you go. 2016, 2016. All right. What happens if we want the entire row? Well, don't specify each or which column you want, just let it run. And then it says, okay, you got row number 0, which is a 5 series 2016, 5 series 2016. It's an Asian, right? It runs on petrol, manual, engine size in liters, 3.5 liters, not bad. Oh, wait a minute. 151,000 kilometers. That has some kilometers. 98,000 for this? Really? Wait a minute. Then what's the real price? What is it? 5 series price. How much did we say? 98,000? 60,000? USD maybe? Is it in something else? 60,000. Oh, someone's getting robbed here. Maybe it's the M5 sedan. I don't know. Maybe. I don't know. But yeah, at least for 151,000 kilometers, I wouldn't pay $100,000. That's insane. Okay, we have 83,000 sales between 2010 and 2016. I'm sorry, 2010 and 2024. Okay, and the sale classification is high. Okay, so BMW actually cares about this data. It says, hey, we have to produce more 5 Series 2016 because we have sold from 2010 to 2024 in 14 years. They have sold 83,000. I'm sorry, 8,300. So 8,300 basically. Okay, cool. Now you can see this as a row. So you can specify, for example, I want 1, maybe a list of 1, 2, and 3. So I get the second column, third column, fourth column. Okay, that's the way you get your data. Okay, cool. And use iLog. Okay, careful with iLog. Okay, I'll comment it here. First number is your row index. Next number, okay, are the columns that you want to add. Okay, awesome. So can you do, hey, I don't know which one of the, like, what is the index of the column price USD. Okay, then you can do df.ilog. It's a list. Get the 0th, and I can do model like this. Say what? Oh, I'm sorry. It's not iLog. It's lock. Okay, there you go. It's the 5 series. Okay, so iLog, you can picture the I as for index. So it's index location 1, 2, 3, and we get 1, 2, 3. If you use lock for location without I, which is not index location but name, you can do model, or I don't know, price underscore USD. There you go. Okay, that's the way to get data. Cool. Now let's speed things up. What happens if I want everything that is newer to 2022? Okay, easy. Data frame in data frame year, like this, bigger than 2022. We're going to print this. Like this. So let's see what happens. Ooh. Then you got the whole thing. You get 6,646 different cars that are above 2022. So 2024, 2023, 24, 23, 24, 24, 30. Yep. See that? Imagine if we have done this here, we actually needed like to do something like this. And then an if statement here. And easily with Pandas, you can do it in a single line. Hey, data frame, I want to get the list of the data frame in year that is everything bigger than 2022. Easy. Okay. Now, for example, Let's do a little bit of data here, or data science actually. Get the cars that are from range 2022 to 2023 and sort. What's wrong with my spelling? Sort by price. Is that complicated? Nah. Check this out. Cars equals a data frame. Okay, you're referring to your data frame. You say, hey, I want to get the data frame in year. We said from 2022 to 2023. That is above 2022. Oh, my bad. And DF in year that is less than or equal to 2023. Okay, you got it. So let's read it again. Data frame. I want to get the data frame from it's either bigger than 2022, so it should be bigger than or equal than 2022, and should be less than or equal to 2023. Okay, so that's the range. Why do we use this instead of a and like this? Because this is a logical and. Okay, so both parties have to be true for this to be true. Okay, cool. So we can do cars dot sort values by what? We can sort the values by year, we can sort the values by price, but we actually want to sort values by price. So by, what was the name of the column? Price USD. Okay. We don't want ascending. Okay, so ascending equals false. Yep. Ready? Oh. Ready? Ready. Where is the price? Where's the price? Okay, it's not as easy to see. Let's do let's do cars. The head. Maybe like this. I got it. It's here, this one. Yep, there you go. Hello. Nice. Now you can see model, year, and we got the first three. The priciest, the most expensive car from 2022 to 2023 range is a 5 Series, again, with 10,000 kilometers, which is decent, really good. $113,000. I'm shocked. Like, what the heck? It says here M5 sedan, 119, like 119,500, and here it says a used one from year 2022 goes for 113,000. Okay, and you'll see with the next dataset, not all datasets are correct. Careful with open source datasets. Okay, some people just hallucinate and put wrong data. Careful. Do your due diligence first. Okay. Cool. Nice. Now here you have it, right? Like we got from the years, we sorted by price and not ascending. Cool. Now, if you're working with data science, one of the very important things that you have to keep in mind is observe your data. Okay, not observe your data, but actually plot your data to observe it. Let's try to do that, okay? We have the plot. Easy peasy. Kind equals line. We'll plot the entire data frame. 3 to 1. Okay, let it think. It's 50,000. Ooh, what? Okay. You know, it's decent. Let me just on Zoom. There we go. It's decent. You cannot see the year. Engine size, you cannot see engine size. You can actually, I don't know if you can see it, but there's a small line, an orange line here. Price USD, mileage, sales volume. But that doesn't make sense, right? Like, yeah, you're seeing your data. For example, year, it's not more than 2024, and it's not less than 2019. Yeah, exactly. And not only that, the year is a very small number compared to a mileage, which mileage is close to 200,000. So you can understand this. Like, you just see it and say, hey, this doesn't make sense at all. And by the way, I don't know if you saw, but you cannot plot, at least for a line, you cannot plot strings. Pandas by itself remove that for you. Okay? So yeah, it's too many data points. Plus, the highest number is very far from the smallest number in your data set. So you won't understand what's happening. Okay? So it's easier to say, hey, Mr. Data Fry, please group by, I want to group by model, like this. And from the model, from each model, yep, I want you to compress all of the models that we have, maybe like 10-ish models. And I want you to get me sales volume. I want you to give me the mean of this. And I want you to plot it as a bar plot where my Y label equals average sales. Okay. Ooh. Okay, what's happening? Okay, what? Maybe some people will say, what? I'm sorry, I got stuck. I want to get everything that the model has and group them. Okay? Make a sandwich out of it. Then I want to get from these groups, I want to get the sales volume column only. Okay? I want to mean them. So I have the average of each. I want to plot it as a bar. And I want to call or title my Y label average sales. So the average sales volume between the entire collection of models, the one that looks visually to be highest is the X1. Yep. Remember, this is the average sales, and by average, X1 is the one that sells the most. Okay, more than 5,000. Okay. Now this is understandable, right? Even numbers are really close. So you might have to change the colors, add here the little numbers so we can understand. But this is more digestible. This is easier to understand. What the heck is this? Not really. Oh yeah. Visually it looks the same. Yeah, you're right. I don't remember how to put the let's look it up together. Pandas add a number in bar plot. Let's see. Bar label. AX containers. What's AX containers? Okay, so should be bar label like that. But this is using Matplotlib. Wait a minute. Can I do? I'm thinking. Maybe set the high limit starting point instead of 0. Maybe set the high limit starting point instead of 0. I got you. But the high limit. So you mean let's put like the high limits should be, or like the starting point should be a little bit less than 5,000, maybe like 4,900. That's what you mean? For example, how can we do that? That's a good question. Group by model size volume mean. Um, that's a good question. How can we do that? Kind bar by label. Let me see if I can get. No. Pandas starting point. I've never done that before. That's a good question. Starting point bar plot. Let's see. To get a bar, pandas use the can bars for vertical blah 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 blah. Blah 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 blah. Yeah. Can you do that? Plotting specific data. Yeah, I know. iLock. I don't want to use iLock. Let's see real quick if we can do that. Bar. Okay, interesting. The data was negative in the first, like at first, yeah, it was negative. What happens if they do this? Axis line from 0. Oh, check this out. But this is using Matplotlib. Wait a minute. Yeah, you have to use Matplotlib then to do it. Yeah. What's the hours? Yeah, no, I don't know if you can add a starting point like that without using Matplotlib. I don't know. That's a good question. Maybe add. What happens if we do just real quick? Do we have a plot here? Basic plot. Do we have the documentation? PLT plot. Okay, maybe the cookbook. Yeah, no, I think we're getting into the rabbit hole here. You can do this. Yeah, I don't know. Okay, I don't know if you can add a starting point without Matplotlib, but yeah, that's definitely a good strategy. Nice. Okay, so let's move on. Let's just forget about this data set for now. Okay. Let's mark down here a little bit. Let's ask ourselves. Expected Python to do that, but maybe not. Well, let's continue for now. Yeah, Matplotlib will do it for you, but you have to plot with Matplotlib, not using this, which I think we'll do in the future with this. Yeah, we'll do it later, okay? With Matplotlib, okay? Cool. So, and please, if someone wants to answer this in the chat, that'd be cool. Are bigger budget in movies? Are bigger budget movies like this, or maybe higher budget movies better rated? So that's our question, okay? Do movies with more budget get more ratings? Well, let's check it out. Let's see if this works. We did at first we did this Kaggle thing, so we don't need to do it again. We just need to import the new data set, okay? Okay, we have one that says nope. I agree. I don't think that budget makes a good movie, but yeah, we have a nope. What would this chat say? Hey, Kaggle datasets. It's a dataset. Okay, maybe a higher amount of ratings, but the average may actually be worse. Yeah, I think so. Maybe by average, it might be worse. I think it depends. It also depends on the actual plot of the movie. But, you know, talking only about budget, I don't think a bigger budget or a higher budget means a better movie. Remember, maybe better effects, not better plot. But yeah. I totally agree. Okay, Kaggle dataset, download. Dash D. Okay, careful. I'm going to send this to you. Ash Pal Sing H 1525. Yeah. I'd say the same thing. It reminds me to IMDb. Give me a minute. Let me just type this because I have one neuron and it's busy typing. Movies data set dash dash zip. Okay, I'm going to send this whole command. Don't worry. There you go. Cool. I hope it doesn't have an error. There you go. Cool. Yeah. So it reminds me of which movie I really liked. For example, Avatar. Okay, the Disney's Avatar. The one that's fire and ice, and it has like the alien movie, the blue aliens. That one. It had a very high budget and it was really loved by people. At least I liked it too. Yeah, Kaggle does a lot of things. But another movie that didn't have a high budget was called Silent Place. Was it that one? Yeah, that's the one. This one, if you haven't seen it, it's really cool. It's about aliens that crash on Earth and they kill whatever makes noise. So the movie's all silent. Okay. They did it that way because they didn't have enough budget to add or to have someone write the dialogues basically. So it was a low budget movie and it became a really good movie. Okay, so it's about the plot, it's not about the money. But yeah. Look at Chupi. What is that? I hope it's not something weird. Okay, interesting. Let's see, budget. Okay, USD maybe? Oh, my bad. Plus minus. 3.5 million? Okay, that's not a lot of money. Okay, at least for a movie, that's not a lot of money. Yeah, I feel like Look at Chupi. I'll watch you Look at Chupi. Awesome. Okay, getting back to our yeah, or less plot points to actually make the movie better. You know, it's a gamble. Okay, we have our data set. We added the dash dash unzip flag here, so it automatically unzips it for us. Shoutouts to Kaggle for that. Awesome. Now, movies dataset equals PD that read CSV like this, and then go to your folder, click on IMDb movies, and then copy path. Okay, again, that's the easiest way to do it. Paste it here. Now, let's first see what this is about. Movies dataset .info like this. Cool. So, okay, we got names, date, score, genre, overview, crew, origin title, status, original language, budget, revenue, and country. Okay, interesting. All of them are non-null. Okay, we don't have a null thingies here, so that's good. Cool. Now, let's check it out. Okay, and by the way, disclaimer: this is a funny, low quality, weird hallucination of a dataset. Okay, just careful with datasets. Cool. Okay, so movies, and you'll see why. Dataset that head. Okay, head means give me the first 5. Okay, cool. We have Creed 3, got a score of 73. Okay, budget, you can see where the hallucination is. It's 1, 2, 3, $75 million for Creed 3. I don't think so. Read 3 budget. It might be. I don't think so. Oh, but with a D. What the heck? 75 million. Okay. Now the one that hallucinates is me. Okay. Let's see. Avatar. Okay, this is actually accurate. Okay, check this out. Our Avatar, The Way of the Water. It's 460 million. One, two, three. One, two. Yeah, it's 400. Really? Damn. Yeah. 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 You know what? I totally understand. Everything is CGI. Like there's nothing that's not CGI. So the actual amount of computing, engineering, and design that you need for every movie like this is crazy. 460 million. Wow. What's the revenue? Actually, we should check this. And the revenue is, oh damn, 7.24 to the power of 8. Let's do revenue. Let's see it here. $2.32 billion. You know what? Good for them. You know what? How many i5s or i8s can we buy with that? I don't know, but that's a lot of money. Hey, for 460 million in for investment, like as an investment, yeah, I get it. Good. Okay, now let's go with another one. Supercell. Supercell movie and it's budget like this. So let's check it out. Supercell 2023 low budget. Okay. Alec Baldwin, yeah, but it doesn't say how much. Okay. 31,000? I don't think so. Really? $31,000? No, it says here. Okay, so this is maybe something. 2023 IMDb. Okay, I don't know what this movie is about. I won't waste a lot of time in the movie, but you can see that, for example, here it says no for financial details. Yep, full financials. I said we don't have the budget of this. Yep, I don't know. It doesn't say, but at least here it says. One says, no, Clash of Clans. Yeah, would have been cool. But no, it's another one about maybe like a I don't know. It says thriller. I don't know. Okay, so this one says low budget on internet, but here it says it's spent $77 million. Okay, that's not low budget. That is not for me. But yeah, okay, just careful with your data sets, okay, and you'll see why in a second. So let's continue with this. Let's not waste time checking if Supercell is actually $77 million in budget. My iPad just crashed. Wait, what? Let's see. Intro to Pandas. This iPad is 10 years old. Still going though. It's really good. I don't like Mac. I don't like Apple. But I do love iPads. Yep. That's what I'll say. I don't have an iPhone. I have a Samsung. I prefer it. People don't like it, but I do. I don't know. It's you know what? I have a Samsung S25 Ultra. Really cool, stable, fast, good camera. I don't know. Yeah. People will say, "Hey, iPhone is better." I don't. No, not really. No. No. The battery is not there. No. But just I don't know. No, I'm sorry, Apple. Yeah, I'm sorry, Apple fans. Okay, cool. So let's filter the data set and let's get names, score, and budgets. Okay, that's what we need out of this. We need the score, the budget, and the name. Okay, because the question is our budget, higher budget, better ratings, Okay, so let's do filtered equals movies dataset, and let's get names. Let's get score, and let's get budget X. Cool. Now, always check your data. Please, 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 if you're working with data, always check. Okay. Okay, we can see Creed 3 has a score of 73 and a budget of $75 million. Avatar, 78 score, $460 million. I'm going to use correlation matrices here. I don't think so. Cool. I don't think so. I don't remember. You'll see. I don't think so. Maybe? Well, wait a minute. Nope, we won't use that. No, we're going to plot and scatter and see how it looks. Okay, cool. Nice. Now, what's the worst movie in this dataset? Min score equals filtered in score dot min. Get the minimum score of the filtered data frame. Max score equals filtered score dot max. Okay, awesome. Now, what was the worst movie? Equals filtered in filtered score is equal to min score. Okay, so again, we get the filtered where the filtered score is equal to the minimum score. Okay, same thing for the best movie. Filtered. Why am I missing an E there? Filtered in score where score equals to max score. Okay, so okay, let's get all of the worst movies. Some movies have the same score, so let's check it out. Right? Worst movie actually should be with S. There we go. Most movies that their names, we're gonna get the names, score, and what we need, budget X. Awesome. So again, before I say that, I show this disclaimer. This is weird. Okay, this is gonna be really weird. But okay. So it says Fast X, which I think it was a really good movie. The score is 0, and the budget is $340 million. Yeah. Is Riders of the Beast the one? Is this the one? Yeah, this was horrible. Okay, so we went from this, or we went actually to from these cool movies, like from this. Yeah, this looks cool. Rendering is great. We went to that. That was horrible. Okay. Can a score be 0? How can a budget be 1 as well? Ah, that's a very good question. I like a lot of Transformers. Yeah, me too. I didn't like that movie. I think they could have done a way better job at designing them. How can a score be 0? How can a budget be 1 as well? Exactly. That's the hallucination part of this dataset. That's your job as a data scientist to get rid of. You can say, hey, Daddy Owl used only $1. I don't think this is important, right? So what you can do is you'll do worst movies dot drop. Was it dot drop? I think. Um, I forgot the function. Drop row in Pandas. It was it iLog. Yeah, it's drop. Yeah, there you go. So we go to dot drop, and then the actual index of this is 10,000 or 10,087. Okay, 10,087. Okay, done. And now the last one is 9877. See that? 9877. Yeah. You can also drop them based on the values. Now, remember, we already filtered it to be the minimum score. At least for this data set, it's 0. Okay. So what we can do is by budget X, say, hey, if the budget is less than $1 million, let's just get rid of it. Okay, you can do that, and that's your job as a data scientist, is to get rid of weird data. Okay, for example, Daddy Owl, what the heck? Or okay, Detective Conan is good. $131 million, really? What the heck is going on? But yeah, okay. So what are the best movies? Anyone want to take a guess? Oh, by the way, best movies. Okay. Yeah. Again, I'm sorry. Yeah. And check that out. The score 100. I'm like, what? Yeah. 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 I mean, yeah. I mean, I don't know what this is. Yeah. I mean, we have to be careful with data sets. Data sets hallucinate a bit. And I think our dear friend, Ash Pal Singh, kind of hallucinated a bit with this data set. I mean, having fast X with 0 and female boss hooker with 100. I mean, maybe someone, maybe your friend, but yeah, no. Yeah, I don't think those types of movies have 200 million of budget. I mean, what? Yeah, I'll maybe become a director. Maybe that's gonna be the easiest way. Okay, cool. Now, let's plot the budget versus the score. Okay, let's see it, because we're just seeing the numbers. We have a lot of numbers. Let's just see the numbers. Filtered equals. Oh, actually, filtered dot. Wait a minute. What's filtered? Oh yeah. Filtered is, remember, is the movies dataset only with name, score, and budget. Okay, so filtered dot plot dot scatter. Okay, scatter is a lot of points. Okay, you scatter, you put lots of different points. X being budget X, and Y being score. Okay. Now, plt.x label. Yep, add your labels, because if not, you won't understand. It should be budget USD. plt.y label, or plt.title movie score versus budget. Okay, and then plt.show. Say what? Filtered budget. I'm sorry, budget with T. Budget X. Again, but say what? plt.x label. Say what? PLT is not defined. Oh, my bad. Import matplotlib the type plot as PLT. My bad. There we go. Okay, so forgot to import this. My bad. Okay, this is how it looks. And you can see that, for example, this value right here, which is $1 billion, nearly $1 billion, it's just one of a kind. Okay, chat, vote. Harry Potter 2 or 3? I vote for 3. Chat, just put your either 2 or 3 in the chat and let's see which movie is best. I think Alfonso Cuarón's movie is better. I liked it. But yeah, if you like Harry Potter, just choose between 2 or 3. Okay, you can see that this doesn't make sense. These 3 movies don't make sense. These whole movies that have score of 0 don't actually make sense. Yeah, also 3 is better. Yeah, I think 3 is better. And yeah, you can do, but good luck doing that here. Like, this is all individual points. So yeah, you can add it, but I won't do it because it'll look horrible. Okay? But for example, you can look for it. For example, you can add a line here and you say, hey, anything after $2 million is nothing for me. And anything under the score of 20 is nothing for me. So you just concentrate on this cloud of points. Okay, because these are going to add a lot of noise to your models, and it's not good. Okay, so that's what you can do. For example, something that you can do is check the correlation coefficient. The correlation coefficient is to see if the points are actually correlated between the x and the y value. Okay, let's check that. Correlation equals filtered. That's the data frame that we have. By the way, chat, again, 2 or 3. I'd say 3. I'll just leave that here. Filtered, and then because I like Harry Potter, by the way. Budget x. The correlation. Oh my bad. It's outside the correlation. Filtered in score. Okay, so we want to get between budget X and score the correlation. Is it related or not correlated? Okay, cool. Now print correlation between the budget and score. I think the comments are being non-stop. My own comments and you can back to the really? Really? I think comments are repeating non-stop. How is that possible? That's weird. Okay. So correlation. Yeah, that's bad. Something negative is bad. Okay, let's check the correlation coefficient at 100%. 1 is your 100%. It means, hey, your x and y values are actually correlated. Okay, if you get 100%, it's bad. Okay, it's really bad because you have a straight line, or it's not a straight line. It should be like a 45-degree line that goes perfectly, and you don't want data like that. But you don't want minus 0.23. That's horrible. It's not correlated at all. Why? Because all of these dots here outside of the cloud are actually creating you the noise. You, as a data scientist, have to get rid of all of the noise. I would recommend anything under 20, and anything over 2.5 million should get out. Or actually 200 million, maybe 250 million should get out. Okay, because you have these 3-4 individual points that add a lot of weight because they're really far. Okay? No. It means the data by itself, the score and the budget are not related, at least not in this data set. Why? Because you have a lot of noise. Okay? So if you get rid of this, maybe you'll get a better correlation coefficient, and you got to check the correlation coefficient so that you understand if your data is related or not related. Okay? If it's not related, it's like a random numbers. If it's related, it means, hey, more budget, more ratings, or less ratings, more budget, or less ratings, less budget, stuff like that. Okay. It means it doesn't make sense. Yeah. So it has to be close to 1. So it's a good number. Okay. If it's less than, if it's like 0.3, it's kind of weird. If it's 0.9, it's too good. You have to check your data. If it's 0.7, 0.8, it's good. Okay. Cool. If you get negative numbers, it's just super bad. Okay. Cool. Now, let's just do something real quick. Let's actually decide with this dataset if actually more budget or more score equals more budget. Okay, let's do it mathematically with the data. Import numpy as np. Yes. Yep, exactly. Yeah. Yep. Cool. So x equals filtered in budget x. Y equals filtered in what is score? Okay, we got it from here. Okay, budget and score. Okay, cool. So if you get a correlation index of 1, it means you have a line like this, like a 45-degree line, and that's not bad. That's not good, because that means that your data is too perfect, and it's just, you won't do anything with it. Like you can work with data like that. It has to be like a cloud of points like this, not a 45-degree angle. Okay, cool. So we have to fit a line. Okay, so we have to take all of the points and we have to linear fit this so we can get a trend line. Okay, easy. MB, which is your what's this called in English? It's the wait a minute, the line equation. M was the, there we go. The name is the gradient. Yep. I think the other name is, there's another name. Oh, the slope. There we go. Slope and the y-intercept. Okay. So from all of these points, we're going to get the slope, which dictates where the line will go, and the y-intercept, which dictates where it intercepts this line. Okay. So let's do np dot plot the phi like this. I'm sorry, polyfit. Sorry. Polyfit. Poly with ly. Fit. And then x, y, and 1. Okay. Cool. Now, PLD the scatter, as we did before. We scatter x, y. Alpha equals 0.6. Okay, just visually, we'll reduce the alpha so the dots are a little bit more transparent, easier to understand. Now, PLT the plot x. Then we have to do m times x, yeah, for the line plus v. Okay, this is the line equation. Okay, and then color is going to be equal to red. Okay, PLT did x label budget in USD millions with small I. PLT did y label, or let's do 0 to 100. Is it 0 to 100? Yeah. And then PLT the title. Always add a title. Score versus budget with the trend line. PLT the show. Ready? Oh, great. X, Y, and comma. There we go. Why did I add 2 commas here? My bad. Oh, there we go. statistically, mathematically, using the line equation, the data set says more budget decreases the score. Maybe, maybe not. The bad thing is, as here this person said, it's Minansh. Okay. We have a lot of values that are noisy, especially these values right here. Like, I don't think any movie would get a 0 IMDb rating. Like, picture this. We are 100. How many humans we are? Humans on Earth. 8.3 billion. Okay, out of 8.3 billion, let's say that half of them watched that movie, okay? So half of the people, 4.15 billion people, no one went to IMDb and rated at least a 1 a movie? I don't think this exists. Yeah, exactly. Yeah. So, like, come on. Like, that director's partner, either wife or, like, their partner. Come on. Like, at least one person has to like it. 0, this just creates or has the line decrease. And yeah. And no, it's not the average. Or you can see it as the average. Yeah. But it involves the trend. So you get the average, and then you add a slope to it based on all of the points. And that slope is the one that dictates your trend, either up or down. Okay? But we don't have zeros. And movies with more than $3 million, or actually $300 million onwards, are weird movies. Like, not even Avatar. Avatar had 240 million. So that's... Yeah, no, it's fine. But yeah, that's it. Yeah, so you can see that you have a lot of noise. Careful with the noise. In this case, anything under 20, I would delete it. Anything past $240 million, I would delete it. Okay, if you do so, we don't have time to do it, but if you do so, you'll get a better understanding of what's happening. Okay, so when you're working at Netflix, at other companies, and they'll ask, hey, I want you to give me a trend line of X and Y, you'll get to do it. Okay, that's how you do it. Use Pandas, or maybe use what was it? What is the other one? I remember. I forgot. I'm sorry. Polars. Yeah, I'll check Polars out and see if it's cool. Okay, awesome. So before I hand it to Alberto once again, here is the link to register, and please go to this link that I'll be sending just now. Awesome. Okay, so this is a Global Hack Week feedback survey that we always do after a stream. Click on continue, and then just look for this stream, which is 101. There we go, Data Science 101 with Pandas. If you really liked it, give me a 10. If you didn't like it, give me a 2 or a 1. I don't get, like, nothing's personal. I know. It helps me grow and become a better streamer. So please be honest. And let me know if you liked or not the stream, so I can stream better. Okay. And yeah, it takes a couple of minutes. So yeah. Oh, thanks so much. Someone liked it very much. Awesome. Can you display the code above last graph once more briefly? Yes. Okay, so I'll go through the code again. You get your budget, and you get your score. And then after that, you get M, which is the slope. B is the y-intercept. Okay, slope is the direction of your line, either going up or going down. Okay. Then you polyfit, which is getting all of the points, getting an average, and then getting that either up or down trend. And then you say, hey, I want to use X, which is budget X, Y, which is score, and alpha is just your transparency in your dots. I want to scatter this. I want to plot it. M times X plus B is your line equation. You can see it here. There you go. Line equation is here. Or here. No, not this one. Here it is. Mx plus B is your y-intercept in this case, and is the line equation. Okay? And then label everything, and then show it. Okay? Oh, awesome. Thank you so much. Cool. What was the puppy thing going across the screen? I love it. A cute app. Okay, so it's Google Colab. If you go to Tools, Settings, Miscellaneous, you can get either a corgi or a crab. Let's wait for the crab, and then I'll just finish the stream. Alberto, just give me 1 minute. There we go. There's a crab. Yeah, it's fun. At least you're not, you know, slowly dying after coding. You're just watching a crab pass by. Can you have all 3 of them? Yes, you can. Go to Settings, Miscellaneous, all 3 of them, Save. Corgi and a cat should pass right away. There's a corgi. And yeah, awesome. And a cat should pass right away. Awesome. Thank you so much for watching. Again, my socials are here. And yeah, I'll see you around. Thank you so much for joining. And yeah, I'll see you next little hack week. Happy hacking. And if you need or want or interested in the fellowship, let me know. Ping me a lot on Discord, and I can give you some tricks and tips and information about fellowship. Okay. Take care. Bye bye.